Good day, future engineers. Let's proceed with our third example. We have here, at this instant, we have cars A and B traveling with speeds of 18 meters per second and 12 meters per second, respectively. Also, at this instant, A has decreased in speed of 2 meters per second squared, and B has an increase of 3 meters per second squared. Determine the velocity and acceleration of B with respect to B. Okay, let's first write our what are given here. You have the velocity of the A is equal to 18 meters per second. We also have the what else? The acceleration of the A is equal to we have a decrease in speed of 2 meters per second squared. We also have what else? The velocity of the B is equal to 12 meters per seconds. And the acceleration of the B is equal to 3 meters per second squared. We're also given with the radius of curvature for our B, which is equal to 100 meters because our particle B or the car B is moving in a curvilinear path. Okay, let's try to solve the velocity using vector analysis. So the velocity of the B that is moving downwards, so that is a negative 12 I hat, is equal to velocity of the A. So you can see the velocity of the A is moving in that direction. And then this is inclined at 60 degrees. So it's x that is just equal to a negative uh, because it moves towards the left. You have a negative 18 cosine 60 I hat minus 18 sine 60 j hat for its y component. That's the relative velocity of the B with respect to A. Ganong relative velocity of the B with respect to A, di I. Because we have here B with respect to A. But if bali ang gipangayo, then we'll be using the relative velocity of A with respect to B. So we just combine like terms. We have the negative 12 I hat to be added with the cosine 8 and cosine 60. That is so that is just equal to we have a negative 12 and 18 cosine 60. So here the relative velocity of the B with respect to A is equal to negative 3 I hat plus the 18 sine 60, which is equal to 15.588 J hat meters per seconds. So the magnitude of the velocity of B, relative velocity of B with respect to A, so you just square those values, that is just equal to 15.875 meters per seconds. How about the direction of this relative velocity? So we have here a negative 3 and a positive 15.588. So its direction with respect to s is equal to then inverse of 10.588 over 3, or the direction of the relative velocity of B with respect to A is just equal to 79.106 degrees. That is from the horizontal. Again, the direction of the velocity acceleration should be measured from the horizontal. Now, how about the acceleration? Let's try to solve them using the vector analysis again. The absolute velocity acceleration of B is equal to the absolute acceleration of A plus the negative plus the relative acceleration of B with respect to A. So what is the acceleration of the B? So the acceleration of the B has two components. You have the tangential and the normal component. So let's solve the normal component, that is just equal to square of the velocity over the radius of curvature. So we have 1.44 meters per second squared. Don't forget the units. So uh we have here what? So yung normal acceleration. So this is our particle B or car B. That is the direction of the normal acceleration of B. So we have a negative 1.44 I hat, and then another acceleration which is negative 3 J hat is equal to the acceleration of the A, that is 2 meters per second. Upwards. So nag-siya do ka component, we have the 2 cosine 60 I hat plus 2 sine 60 J hat plus the relative acceleration of B with respect to A. So we just combine the like terms, and we can obtain, we have here a negative 2.44 I hat minus 4.732 J hat meters per second squared. To get the magnitude, just square those values. To have 2.44 squared plus 4.72 squared, then the magnitude of the acceleration, relative acceleration of B with respect to A is equal to 5.324 meters per second squared. And its direction of the acceleration of the relative acceleration of B with respect to A, so that is towards the left and downward. We have 62.72 degrees on this direction. So, kung ano siya, no? Dali lang ang iyang idea. You just determine what are the given the velocities or acceleration, what we're being asked. If the particle is moving along a curvilinear path, of course, you need to consider its normal and the tangential components. And then you just apply which analysis is much better, the vector analysis or the scalar analysis. Or actually, you might be using the triangle method, and then you can use the cosine law and the sine law in solving these problems. So this is the relative motion of two particles. So hope you learned something, and if you have any question, you can just raise your questions to me anytime.